Good morning. This is the continuation of our last class on Laplace transform. In today's session, we will learn a few theorems on Laplace transform. The first theorem is Laplace transform of the sum of two functions will be the sum of their Laplace transform. So, suppose that you have two functions f of x and g of x. Now, the Laplace transform of the sum of those two functions will be equal to sum of their Laplace transform. You know, a Laplace transform of f of x equal to 0 integral 0 to infinity e raised to minus sx fx dx. So, Laplace transform of f of x plus g of x will be this one. That is, in place of f of x, you are having this quantity. And now you just split this into two. This is nothing but L of f of x and this is nothing but L of g of x. This can be written as f of x and this can be written as g of x. So, that means Laplace transform of the sum of two functions will be equal to sum of their Laplace transform. That is the first theorem on Laplace transform. Now, second theorem. Laplace transform of a function and a constant is that constant multiplied by the Laplace transform of the function. That is, suppose that you are having a function f of x, it is multiplied by a constant, say k. Then just take the constant outside k. Then what remaining will be the Laplace transform of f of x. Now, the proof, Laplace transform of kf of x equal to integral 0 to infinity e raised to minus sx. In place of f of x, we are having kf of x. K is a constant, take it outside. Rest is kept as such. Now, here also k is kept as such. This is nothing but L of f of x. Okay, that is a second theorem. Now, combining these two theorems, we will get another theorem, that is Laplace transform of k1 f1x plus k2 f2x is equal to k1 L of f1x plus k2 L of f2x. That is, you have two functions f1 and s and f2x, and each of those functions is multiplied by a constant, say k1 and k2, and then you are taking the sum, and finally you are finding the Laplace transform. So that's nothing but combination of the first two theorems that you have just learned. Okay, so this is its proof. This is written, you are splitting it and then you are taking the constant outside. So this theorem is also called linearity property of Laplace transform. Okay, now we will just do a problem. That is the first formula that we have derived in our first class on Laplace transform was, what is it? Laplace transform of e raised to x, right? That is equal to 1 by s minus a. Now suppose that in place of e raised to x, you are having e raised to iax. Then instead of 1 by s minus a, you will have 1 by s minus ia. Now multiplying the numerator and denominator with its complex conjugate, say s plus ia. Now e raised to I theta, you know it is cos theta plus I sin theta. So e raised to ix will be cos x plus I sin x. Then its Laplace transform. Now on simplifying this, you will get s plus ia by s square plus s square, right? Now you just split the real and imaginary part of this one. You also split the real and imaginary part of this one. On splitting, you will get this as this one and this one as this. Okay, now you just equate the real part and imaginary part on LHS and RHS. On equating the real part, you will get Laplace transform of cos AX equal to s by s square plus a square. This is in good agreement with the formula that we have derived for Laplace transform of cos AX in our first class. What was it? S by s square plus a square. Okay. Now, equate the imaginary part, that is Laplace transform of sin AX. It will be equal to a by s square plus a square. This is also in good agreement with the formula that we have derived for the Laplace transform of sin AX in our first class. What was it? A by s square plus a square. Okay. So this is another way to derive the formula for sin AX and cos AX. Okay. So we have derived the formula for Laplace transform of sin AX and cos AX. Now our aim is to derive the formula for the Laplace transform of sin HAX and cos HAX, that is hyperbolic function. For that, let us begin with cos HAX. Okay. Now, you know cos theta can also be written as e raised to I theta plus e raised to minus I theta by 2. Similarly, this one is also written in that manner. Now, you just split it into two, that is half Laplace transform of e raised to ax plus half Laplace transform of e raised to minus x. Half is common, take it outside. This one is 1 by s minus a, this is 1 by s plus. On simplification, you will get the formula to find the Laplace transform of cos HAX as s by s square minus a square, not this formula. Okay. Now, for sin HAX, procedure is the same. The only difference is in the first part, that is sine theta can be written as e raised to I theta minus e raised to minus I theta by 2, right? So on simplifying, you will get the answer as a by s square minus a square. Okay, learn these two formulas well. Also the derivation. So Laplace transform of cos h a x is s by s square minus a square, and Laplace transform of sin h a x is a by s square minus a square. Okay. Now another theorem. If f of x is equal to f of s, then Laplace transform of e raised to x f of x will be equal to f of s minus a. That is, here in between you are having e raised to ax. So your formula in place of f of s, it will become f of s minus a. Okay, so just begin with the formula. Laplace transform of f of x equal to integral 0 to infinity e raised to minus sx fx dx can be written as fs. Now in such case, what will be f of s minus a? In place of this, you will have e raised to minus of s minus a. Okay, now just split this into 2, that is e raised to minus sx into e raised to ax. Okay, now this is nothing but Laplace transform of e raised to ax f of x. So that is a theorem. So when you get problems like this, you first understand that this is of this form. We will do one problem. See, this you know. This is of the form sin 80 or sin ax. What is the Laplace formula of sin ax? A by s square plus a square. Okay, this is your a2. So a by s square plus a square. So if instead of this you are having a e raised to term, that is, if you are having e raised to 3t also in the sin 2t, that is, then you will understand, you must understand that this is of this form. Okay, then your answer will be f of s minus a. So what you have to do is, you have to, if you have a e raised to term in addition to the sine term, first write the expression for sin ax, that is, write this one, and after that you are having, just subtract this 3 from s. Okay, 2 is kept as such. Instead of s square, you have to write s minus 3 the whole square, and 2 square is kept as such. Okay, because here you have a e raised to 3t. Okay, that is what it is said, that answer will be f of s minus a. Okay, now if you are having another problem, cos 4x. If it is cos 4x, then you know it is s by s square plus 4 square. But if you have an e raised to term also, what you have to write? In place of this yes, you have to subtract the exponent of e. That is, here you are having a minus 1. So on subtracting that from s, that is subtracting minus 1 from s, it will become s minus of minus 1. So it will become s plus 1. Okay, like this. So when you are given a problem, just note it, okay, before writing the answer. Don't be in a hurry. That is, now another one, x raised to n. You know the Laplace transform is n factorial by s raised to n plus 1. We have already derived in the last class. So if instead of this x raised to n, if there is an e raised to term, that is e raised to ax xn, then what will you do? You just write n factorial by s raised to n plus 1. Then from s you are subtracting that coefficient, that is a, s minus a. Okay. Now similarly, you are having obtain Laplace transform of e raised to s cos h omega s. Just now we have derived the formula for Laplace transform of cos h omega x. What was it? S by s square minus omega square. Since you are having an e raised to x term, what you have to do? You have to subtract this a from s. So your answer will be s minus a by s minus a the whole square minus omega square. Okay. Now another theorem. If Laplace transform of f of x is f of s, then Laplace transform of x f of x, that is, in f of x, you are, instead of e raised to x, you are having x. If that is the form of question that you have, then your answer will be minus df by ds. That is, you have to take the derivative. Okay, so let us see. This is the function integral 0 to infinity e raised to minus sx fx dx. You know it is f of s. Now just differentiate it. That is df by ds. What is the differential of e raised to minus sx? It will be minus x e raised to minus sx. Then fx ds is kept as such. Now this here there is a negative sign. You just take the negative sign only outside. Rest everything is kept as such. So negative is kept here. This one is retained as such. This is nothing but Laplace transform of x f of x, because you are having an x here. So it is Laplace transform of x f of x. Okay. So Laplace transform of x f of x is equal to df by ds. Now in place of x, that is x means x raised to 1. Now if you are having x square there, then your answer will be minus 1 the whole square d square f by ds square. Now similarly, if it is x cube, then it will be minus 1 whole raised to cube d cube f by ds cube, right? That. Now if it is x raised to n, then it will be minus 1 whole raised to n by d raised to nf by d s raised to n. Okay. Now here is an example. E raised to x, you know it is 1 by s minus a. Now here see you are having an x here. So what will be your answer as per the question? Minus 1 whole raised to 1 by d ds. Okay. So the first derivative, you just take the first derivative of this. First derivative of this will be this one. Then if you are having x square, what was the formula that you have learned? It will be minus 1 the whole square d square f by df square. So you have to differentiate this one more time. Okay, and put a negative sign also. Negative 1 the whole square, so it will become 1 itself. So on differentiating this once again, you will get this answer. Okay, that is how it follows. This is another way. You can just work it out. Now, Laplace transform of x sin omega x. Another question. Sin omega x, you know what is the value? It is nothing but it is of the form sin ax, that is a by s square plus a square. So sin omega x will be omega by s square plus omega square. Now you are having x there, so you have to differentiate it once. On differentiating it once, you will get the answer like this. Similar is for x cos omega. So you know Laplace transform of cos omega x equal to s by s square plus omega square. But you are having an additional x, so you have to differentiate it once. Okay, so just apply the rules that you have studied here. Okay, then you will get the answers for x sin omega x and x cos omega x. The Laplace transform of x sin omega x is 2s omega by s square plus omega square the whole square, and for x cos omega x it is s square minus omega square by s square plus omega square the whole square. So these two questions are important. They may ask it. So just work it out. So first study that theorem, corresponding theorem, and then you work out these two problems. Okay. Now another form. If Laplace transform of f of x is fs, then Laplace transform of f of ax will be equal to 1 by a f of s by a. Okay. So this is the formula that we already know. That is for f of s. Now for f of s by a, what are the changes that you have to make? In place of this s, you have to write s minus of s by a. Okay. Now just put x by s y. Then dx will be a dy. When x equal to 0, y equal to 0. And when x equal to infinity, y equal to infinity. Therefore, on applying these conditions, your equation 1 will become like this. A is a constant. Take it outside. Rest everything is kept as such. This is nothing but Laplace transform of the function ay, and that is same as Laplace transform of f of ax. Okay, we can change because we are concerned with the x, so we can replace this ay as ax. There is no matter. So finally we will reach the result as Laplace transform of f of ax equal to 1 by a f of s by a. This is just a theorem and its proof. Now the final theorem, Laplace transform of f of x equal to fs, then Laplace transform of fx by x equal to integral from s to infinity ft dt. So they are given a question, obtain Laplace transform of sin x by x. Okay, so here you are having x as denominator. So first you understand that this is of this form. In such cases your answer will be integral s to infinity ft dt. Okay, like this. Now integral s to infinity ft dt will be equal to, here in this case, for sine square, for sin x, Laplace transform of sin x. Okay, what was it? A by s square plus a square. Here a is 1. So Laplace transform of sin x will be 1 by s square plus 1 square. Okay, so here everything is written in t. So you write this 1 by s square plus 1 as 1 by t square plus 1 dt. Okay, now what is integral of 1 by t square plus 1? It is tan inverse t, that you might have learned in 12th standard. Tan inverse t, integral 1 by t square plus 1 is tan inverse t, or tan inverse x is equal to integral 1 by x square plus 1. Okay, then apply the limit. Tan inverse infinity minus tan inverse s. Let tan inverse infinity be alpha and tan inverse s be beta. Okay, equation 1. Now what is tan a minus b? Tan a minus tan b by 1 plus tan a tan b. Okay, here in place of a you are having alpha and in place of b you are having beta. Now just divide numerator and denominator by tan alpha. Your answer will be 1 by tan beta. That is nothing but 1 by s. So alpha minus beta is, tan alpha minus beta is 1 by s. So alpha minus beta will be tan inverse 1 by s. Okay, so equation 1 will become Laplace transform of sin x by x. The formula is tan inverse 1 by s. Okay, so this is a formula. You will be asked only problems based on this. So Laplace transform of sin x, you know it is a by s square plus a square. Now Laplace transform of sin x by x. Sin x by x will be tan inverse 1 by s. For your exam, your question will be like this. Obtain Laplace transform of sin ax by ax. Okay, you know the formula, that Laplace transform of sin x by x equal to tan inverse 1 by s. So you just write it first. Now here your question is sin ax by ax. Okay, so it will be tan inverse 1 by, so this is of the form 1 by a f s by a. Okay, 1 by a is kept as such. Then tan inverse s by a. Okay, so s by a. Here you have sin ax by ax. So tan inverse 1 by s minus a. On taking the reverse, it will be a by s. So 1 by a tan inverse a by s. This is a formula for finding this one. Okay, so just learn this formula, that is Laplace transform of sin ax by ax equal to 1 by a tan inverse a by s, another formula. Okay, so Laplace transform of sin ax by ax equal to 1 by a tan inverse a by s. So based on that, we will have a problem. Sin 3x by 3x. You are asked to find the Laplace transform of sin 3x by 3x. So first identify that this is of the form Laplace transform of sin ax by ax. What was the formula? 1 by a tan inverse a by s. Here your a is 3. So your answer will be, in place of a by s, that is, if you are given a question like this, you first identify that this is of the form sin ax by ax. Laplace transform of sin ax by ax is 1 by a tan inverse a by s. Here your a is 3. So this answer will be 1 by a, that is 1 by 3 tan inverse 3 by s. Okay, so study this formula also. Okay, so go through the theorem first and then work out one or more two problems based on those theorems. Okay, thank you.